Okay, question 3. Terry knew that carbon and aluminum oxide will react to produce aluminum oxide. Oops, I got a typo there. I double typed that one. Okay, so Terry knew that carbon and aluminum oxide will react to produce aluminum and carbon dioxide. If Terry had a container of 5 molar aluminum oxide in his supply cupboard, how many milliliters would it take for him to prepare 500 grams of aluminum base upon his reaction? Okay, all right, our first step, as always, is writing and balancing the equation and underlining the components we're interested in. So we have 3 carbons plus 2 aluminum oxides yields 4 aluminums and 3 carbon dioxides. We're looking at the aluminum oxide and the aluminum. Now we know from the question he wants to prepare 500 grams of aluminum. Okay, so we need to know how many moles so we can apply the mole-to-mole ratio. So we'll convert grams to moles. 500 grams of aluminum times 1 mole of aluminum is over 27 grams of aluminum. That's our molecular mass of aluminum, and that equals 18.5 moles of aluminum. So right now we know that he wants to make 18.5 moles of aluminum. Okay, so we're going to try and find out how much aluminum oxide he needs. So we apply the mole ratio, which we didn't discuss this time, but it's 18.5 moles. That's how many we have. And we put moles of aluminum on the bottom, moles of aluminum oxide on top, so the moles of aluminum cancel. So according to our equation, we have 2 moles of aluminum oxide for every 4 moles of aluminum. So we have 2 moles of aluminum oxide and 4 moles of aluminum. Now you could reduce this 1 and 2 if you want. Doesn't really matter. But you multiply that all out and divide, so 18.5 times 2 divided by 4, and you get 9.25 moles of aluminum hydroxide, or aluminum oxide, sorry. Moles of aluminum has canceled. Okay, so now we know how many moles of aluminum oxide we need, but we need to figure out how many milliliters in our 5 molar aluminum oxide solution. So we expand our molarity to moles over liters. So 5 molar aluminum oxide is equal to 5 moles of aluminum oxide in 1 liter. Okay, and then we're going to set up our ratio. 5 moles over 1,000 milliliters is equal to 9.25 moles in X milliliters. So we do our cross multiplying and dividing, and we get 1,850 milliliters of 5 molar aluminum oxide. And that is question 3.